In some cases, we can use a calculator square root, so the square root of 4. Relatively easy to see, the square root of 4 there is 2. And we can say exactly what this is. In other cases, let's think about the square root of 3, we can't write that as an integer. We could work it out on a calculator as a fraction. And so this idea of being able to either to say what the square root is or not leads us to the idea of surds. So this square root of 3 is called a surd. Surd is originally from the Arabic, translated into the Latin, which actually means not able to be spoken. So we can speak this one, we can say what it is, but we can't say what this is. Okay, so surds are interesting. Surds in terms of simplifying expressions are rather unusual. So there's a couple of different ways we might think about simplifying expressions. The first is if we can find an expression which looks like the square root of, let's say, a squared plus b, then this is equivalent to the square root of a squared times the square root of b, and the square root of a squared number is in fact just the number, a. So the square root of 2 squared is just 2. And so we can simplify this expression to a square root of b. So the idea of taking out squared factors outside that square root is important. So for example, if I were to do the square root of 20, the square root of 20 is the square root of 4 times 5. 20 is 4 times 5, but 4 is itself a square number. And so the square root of 20 can be simplified through knowing what the square root of one part of it is, the 4, which is 2, can be simplified to 2 root 5. And root 5 here, root 5 is a surd. I can't write down root 5 as an integer. The other way of simplifying these surds is slightly different, and that's using the idea of simplifying fractions which contain surds. So let's say I've got an expression like this. 1 over a, some number, plus b times the square root of c, where the square root of c here is a surd. Okay, well, what we do is, in fact, we multiply by 1. Well, not quite 1. We multiply by a particularly important version of 1. We multiply by this number, a minus b root c over a minus b root c. That certainly is 1, same expression on the numerator and the denominator, but because of some quite nice little property now, it will simplify our expression. So we're multiplying two fractions, so let's do that. It's 1 times a minus b root c over, and then let's put these in brackets just to be clear what we mean. It's a plus b root c multiplied by this thing here, a minus b root c. Okay, it looks like we've complicated this hugely from our original expression, but let's keep going. Because this, the numerator here simplifies quite nicely. It's just 1 times this, so it is a minus b root c. And if I expand out this expression here, what happens is, just using the normal way of expanding out two brackets, this in fact becomes a squared minus b squared c. Okay, expanding out, doing the a times a gives me an a squared. The b root c times a minus b root c gives me minus b squared c. And in fact, the two other terms in this expression cancel. The b root c times a and the minus b root c times a. So I'm left with this. This looks a bit horrible, but in fact, it's a much nicer form because this is in fact a over a squared minus b squared c minus b over a squared minus b squared c root c. And why is that nicer? It's because now we have no surd in the denominator. We actually have it here in the numerator. If we put every expression in this way, then multiplying things out is far simpler. Okay, I'll just do one very quick example of that. And the example I have is 4 over the square root of 7 minus the square root of 2. Okay, so 2 surds in the denominator here, but it still works. What I do is I multiply by the square root of 7 plus the square root of 2 over the square root of 7 plus the square root of 2. I've not done anything there except for multiply by 1. And what I've done is I've taken the expression underneath here and multiplied it by a particular form that I know by changing this sign, the minus to a plus. If it was a plus, I'd have changed it to a minus, that things will work out in the end. Okay, so what happens? I multiply out this expression. The numerator there is 4 times root 7 plus root 2. 4 times root 7 plus 4 times root 2. And on the denominator here, I get root 7 minus root 2 times root 7 plus root 2. And rather miraculously, when I multiply out these brackets, I get root 7 times root 7. That gives me 7. I get minus root 2 plus root 2. That gives me minus 2. And then the 2 other terms disappear. The minus root 2 times 7 and the plus root 2 times 7. And so what I end up with is 4 root 7 plus 4 root 2 divided by 7 minus 2. The root 7 times root 7 gives me that 7. And the minus root 2 and the plus root 2 give me the minus 2. Well, 7 minus 2 is 5. So I end up with an expression here, 4/5 root 7 plus 4/5 root 2. And so any expression which has surds, these square roots, in the denominator can actually be simplified in this way.